That's why I'd like to go to my presentation today, which is achieving differentiation through premium quality with for solar PV. I work with the VDE Institute in their Energy and Smart Technologies department, and I'd just like to maybe give you a brief introduction as to who we are, for those of you who are not so familiar. So we offer international testing and certification for solar PV, together with our international partners, such as in the US we have CFV, we work with Fraunhofer IGEEC internationally. In China we have CPVT, and in Southeast Asia we have the Solar Energy Research Institute of Singapore. So some of our unique involvements on a national level include, for example, in China, we are the exclusive partner of the China Quality Certification Center for providing technical due diligence on Chinese module manufacturers. This is to help establish their bankability for the financing and insurance sectors. In Japan, we work very closely with JET. And in Germany, we are working closely with the German government to develop stricter requirements for market entry. And of course, we've been a founding member and a long time, we've been working for a long time with the IEC as well. Just to break up the two areas of our service, we provide certification for components, namely, I think some of the interesting points here are modules and inverters, and the upcoming area is energy storage as well. And we also provide certification for complete power plants, as you'll see later on in my presentation. So before I jump into talking about differentiation and bankability, I'd like to first give an overview of global market trends that we see. So I think what we see now is a shift from the old era of solar, where growth was driven very much by supporting programs such as the feed-in tariff system in Germany. And now we see more, growth will be driven more by private sector investment based on unsubsidized project economics. This is also because of what we've seen. A lot of governments have been seeing a lot of burdens from their supporting programs, and therefore these are being scaled down or in some cases canceled completely. So in this new solar era 2.0, we can expect to see that investors and lenders will change their decision-making criteria, and quality will play a crucial factor in reducing technical risk, validating performance and thus financial returns, and achieving differentiation in the competitive market. So in going forward, I think we see a very positive growth for solar energy installations around the world. After a relatively slow 2 years, we see up to 27% growth in 2014 and 25% growth in 2015. So some good numbers there for global installations in the next 2 years. And we also see increasing globalization in new markets as well, such as the Middle East, South America, and Southeast Asia. And although this is good news, it will not be without its challenges that must be overcome in new markets, such as, for example, acquiring finance in a place where the financial industry is not as familiar with renewables. So there's some hurdles that need to be overcome there. I'd like to show you this slide on what's happening in the inverter industry, because as you can see, industry revenues have been going down from 2012 to 2013. It's gone down by 9%. And this is because of, in part of a 18% decrease in average global prices for inverters, but also because we see a high competition in the industry, where we have reducing volumes, for example, in Germany and Italy for inverter supplying, but the same number of suppliers in the market remain the same. So the main takeaway here is that although we have a strong growth in the market, not all sectors of the solar value chain will have such an easy time. So it's not just modules and inverters, it could be any part of the solar value chain. And therefore, the suppliers will need to focus not on providing low prices, but on providing a sustainable product and good quality. So in summary, what we see in the market is positive growth. It's a positive outlook going forward. Module prices are stabilizing. Companies are continuing to invest in capital spending after a long pause in the industry consolidation. But challenges remain because of the changes in government incentives and because of the shift to growth, the growth driver coming from private sector investment. And we expect to see also thin margins throughout the solar value chain. So now that we've seen what's happened in the market, I think it's very important to look at the risks that are being faced in the solar industry. I think for an investor, what they are most concerned about is maximizing the performance of their system. And therefore, it's important to look at system performance risk. And in this sense, system performance risk can be broken down into two main factors. The first being component risk, and the second being system integration risk. On component risk, we see such issues such as quality and reliability. How long will the product last without failures? We see insolvency risk. So if the supplier goes bankrupt, then we have problems, of course, with the warranty. And after-sales service of component suppliers. If there is a failure, how quickly can the service supplier change the defective products? I think the component risk applies to key areas such as modules and inverters, but now also energy storage is a hot topic, especially here, I think, in Korea, and it will be something that we'll have to address. It's probably still in the early range of the bathtub curve, which you see here. So as the technologies as we get more experience from ESS technologies, I think we can expect to see a reducing rate for failures as well. I'd like to show you this pie chart on the causes of system failures in the German case, because what you can see is that it's not only components that we have to look at in terms of risks, but also installation as well. So you can see a big part of failures were caused by improper implementation and installation. And the result for performance, I'd like to show you an example. You can see here the results of different systems that have been tested in Singapore, for example. You can see that there's an 8% variance between the best-in-class performance of a system of 83% and the average performance, which was 75%. So this translates directly to an 8% variance in what could be your return on investment. So now that we've seen the market trends and the risks that we're facing, what are the implications for bankability and differentiation? As mentioned, we see increased uncertainty because power purchase agreements no longer have the same security that they had before, like what we had in feed-in tariff programs. And therefore, this means higher perceived risk for investors, along with their redefinition of their bankability criteria. And so I think that the industry will see higher expectations in overall system quality to maximize performance and returns. Now, what do we mean by overall system quality? Well, we'd like to define it as in three foundations. The first being component selection, the second being system planning and engineering, and the third is construction and execution. So, what do we mean by technical bankability? For us, it means independently proven quality of components and entire systems. And technical bankability forms an important part of overall bankability, including financial bankability, like the different factors you see here. And together, these factors are necessary for gaining the approval of financing for PV projects. So some of we believe that quality is a core part of technical bankability, and it provides three main benefits. The first being the reduction of technical risks for failures of components. The second being the validation of performance of the system and thus validation of your economic performance. And the third means achieving differentiation in the competitive market. So the process for us, we see that the goal needs to be the achievement of differentiation and bankability through quality to increase the trust in solar PV for investors. However, there still remains a gap in that existing quality assurance does not meet the needs of investors to lower technical risk. And so from our perspective, the solution is to establish a new premium level of quality assurance and also a system-wide approach to quality. not only looking at components. And so, just to go through some of the different solutions that VDE has come up with, starting first with the PV module section, we have introduced this VDE quality tested mark for PV module certification. And it has three main features. The first being sharper module design and safety qualification requirements. The second being continuous inline quality monitoring of mass production. And the third is continuous offline process and quality monitoring of production sites. So why do we believe that testing beyond the standards is necessary? I'd like to show you this graph. So you can see here the green box in these two graphs, which display two testing sequences for damp heat testing and thermal cycling. With existing standards, damp heat testing, for example, calls for this duration of testing. However, you see that immediately after the test regulation of 1,000 hours, you see a significant you see a significant drop in power losses, and the same thing with thermal cycling as well. Therefore, under the quality tested program, we believe in optimizing these testing parameters to increase the confidence in the results of the tests. So some of the benefits that we see here is higher confidence in product quality thanks to this continuous product monitoring, proven long-term reliability thanks to continuous product and production site monitoring, and a better return on investment thanks to proven high reliability and low power degradation. We also have expanded this quality tested product to PV inverters as well. So you can see here it builds upon our three layers, starting with legal requirements and unique selling propositions. The idea here is to provide a premium level of quality for PV inverters. It's also based on existing international standards, but has been improved to provide additional benefits to customers. And it focuses on three main areas, namely proven safety, validated performance, and high reliability. So, maybe just to explain why we chose these three areas. I think proven safety is clear. All products need to be safe to handle. And in this area, VDE has over 90 years of experience in safety testing. For high reliability, it's to reduce the risk of product failures and warranty claims. And validated performance is to demonstrate the product's ability to perform according to expectations. And now to round off everything and to address the needs of what I mentioned earlier, where we need to see improved system-level quality assurance, I'd like to introduce you to our new portfolio for PV power plants. So this is it's a comprehensive testing portfolio for the entire system and customized according to the needs of investors and other stakeholders. And the idea here is to provide independent verification of the power plant by highly competent and reputable experts. So here we have two main products. The first being the VDE quality tested mark. This is a very comprehensive quality assurance product, which starts from the early stage of the power plant, where we review concept and design, all the way up to initial operation. We do sophisticated performance modeling of the power plant together with our partner Fraunhofer ISE, and it features over 300 pass-fail testing points to be a very stringent testing program. For power plants that are already in operation, we have the VDE tested mark, and here we do system performance verification based on existing data collected from the power plant and inspection of the actual state of the system. So I think this is especially interesting for products that are, for example, going to be sold in the secondary project market. The foundation of our our power plant portfolio is, first of all, to check against international standards on one part, but the value add here is that we also check more comprehensively against internally developed tests, which draw on the 25 years of experience between VDE and Fraunhofer ISE. And the objectives are to provide a tailored quality assurance product, lower the technical risk of the power plant, and support technical bankability on a system-wide level. So in terms of the technical benefits here, I think there's three main areas. First is electrical and mechanical safety of the system. Second is system performance and energy yield verification. And the third is proper system orientation. And again, relating to the whole theme behind everything is a strong basis for achieving technical bankability. So that's the end of my presentation. Just to recap, I think it's very important that we focus on bankability and differentiation in this market to help address the challenges that we see, and also to survive in the tough industry. So VDE has put together some of these solutions, and we are very pleased to be your partner. Thank you.